Hey everybody, Lars here. Time for the first review video for Big Bad Unit 5. Only Unit 5 isn't that bad. We're going to get 3 review videos for this particular unit, and we'll do some simple announcements at the end. But basically, I'm sitting here Saturday, last day of March. NCAA games are on later on. The Mets have already won. They beat the Cardinals. They started the season 2-0. So today's a big sports day if you're a sports idiot like me. But I needed to sneak in here and get this Python video done, because for the next 2 or 3 days, I'm going to do a video a day. So I can get you all your resources early on in this unit so you have as much time as possible to work on the assignments. And also because next weekend, not really the weekend, I'm going on Wednesday, I'm going to Boston for PAX, which is like a video game conference. So I got to get all this stuff done, get everything front loaded, and I wanted to get you started right as far as Unit 5 was concerned. And basically, Unit 5, as you know, if you looked at the slides already, is about object orientation. And object orientation is not a crazy thing to wrap your head around, as you're going to see, but it's a different way to think about and a different way to write our programs. Basically, in the history of programming, you had the early days where you just had these big machines, and all of the programs were written, like custom written for just those machines and just that architecture. Then in the late 50s, Harvard Basic. In the 60s, you had Basic and Fortran. And in the 70s, you had languages like Pascal, where you had higher level languages, where you would have these languages, then compile them to the ones and zeros that the computer understood. And most of these languages were what we call imperative. And you know this because we've gone over it before. Imperative languages are like recipes. Your data is your ingredients. You have a series of steps and things you go to reach the goal state and get the solution or the answer. So all of a sudden, you know, computer scientists are always playing with better and, you know, more complex ways of doing things and creating languages and things along those lines. So there was some object-oriented ideas in the 60s and 70s. In the 70s, they invented C. And C has this thing called struct, where you can build your own data types. That was kind of getting near. I mean, you could do object orientation without, you know, C++ or Java or anything like that. You could do it yourself design-wise in C. If you become a C programmer, you'll know what I'm talking about later. But basically, for a lot of us, when I say us, I mean people in my age range, 40s, 50s, people who are coming up in the 70s, 80s, learning about computer science, where object orientation really crossed our radar. And I actually went up to the old libraries, the old wizard libraries, and found this book. It was called Squeak. And Squeak was a little system that was implemented in a language called Smalltalk. And Smalltalk, at least for me, was the first object-oriented language a lot of us had exposure to. And it was around the early 80s, like 82, 83. That's high school for me. So it was kind of a niche thing, kind of an interesting thing, but you never really wrote a lot of programs in it, almost like what functional languages were. If you know anything about Haskell or Lisp, I digress, as I usually do. So some people had an idea of what it was, but it was like, yeah, whatever. I'm writing my programs in Pascal, regular structured language, blah, blah, blah. Then C became very popular in the 80s. C continues to be very popular. It's the programmers, it's the computer scientists programming language. And in 1987, a gentleman at AT&T named Bjarne Stroustrup wrote an extension to the C language so that C could handle object orientation. And as you're probably guessing, it was called C++. Plus being an increment or greater than C. C++ is what's called a superset, in that it completely encompasses C. So if you learn C++, theoretically you know C. You can write imperative programs. You can do things with regular C libraries, stdi.h, and you don't have to use the object-oriented libraries. What were they, HPP or something like that? And you could use C out and C in instead of printf and scanf, and now I'm really going crazy, and you guys don't have to understand what I just said. So that's what a lot of people did, because C++ in the late 80s is how you wrote Windows programs. So I also went up to the old libraries, and I don't even know what year this book is. But when I first, 1994, so this was later, this was down the line, but a lot of people, when they bounced out of school, they went and got Borland C++4 to write Windows programs if you were going to be a programmer or a consultant. And All of these things cost money. It costs money to buy a C++ compiler. It costs money for a college to put Pascal on their mainframe or COBOL on their mainframe. You had to pay the people who were, designing these compilers. All of a sudden in 1995, Java comes out, and that just changed the scene completely. Java was hyped. Java was called the language of the internet. Java was, this is the important thing, free. Java was F-R-E-E. Sun Microsystems, I think it was, 1995. Java came out, and every college in the world just implemented it because it was free. All of a sudden, you did not have to pay for your compilers any longer. So if you could do it, you ran Java. And a lot of schools changed over and started teaching in Java and using Java. So ever since then, basically, object orientation and learning about it is here to stay. And it's why I do this unit, because in the real world, when you go out and you start using libraries and you start doing things with other languages and other people and other things, even though you're using Python, you have to understand the basics of object orientation because everybody uses it. Right? What you're going to do when you get libraries now is they're going to have a whole bunch of classes, and you're going to get different objects. My dryer. You're going to get different objects, and you're going to use those classes that are in those libraries, not necessarily just using functions like we learned about at the end of Unit 3. You're going to use classes, and you're going to use the methods that come with those classes and different stuff like that. So that's pretty much the story with object orientation. I want you to know a little bit about it, and I want you to be familiar with some of the topics that are involved with it, so that when you get that data science job and you start doing things, you understand it. So this will be the beginning or your introduction into object orientation. And it's, believe me, everybody, it's almost like recursion. People make a big deal out of it, and you don't have to. It's not that big a deal. It's not crazy. So what we're going to do is I whipped up a shell here, and we are going to really quick whip up a class, and then we're going to get an actual object of that class. We're going to instantiate it and have a variable, and then we're going to use it and play around with it. And what I usually do is I do a checking account. So let's go to it. Let's say class. You can see idle makes it orange, and then I'm just going to call it checking. I'm going to go fast and skip over some stuff, so don't worry. We are going to trace it at the end of the video, and we will be fine. So I'm going to say class checking, and then what do I have to do inside of a class? I have to define all of my functions that have to do with this class, but as I told you in the slides, for whatever reason, in classes and in object orientation, we don't call them functions anymore, we call them methods. So what I have to do is write up all my methods. Now, every class has a method that gets run when you first instantiate it, and you first get a real copy of it, and that method is called the constructor. So what we're going to do, and you can see methods and functions are the same, we're still using def, is I'm going to write my constructor. In Python, your constructor is always called dunder, which means double underscore, init dunder. Okay? Then we're going to open up a argument string, and I'm going to put in the variable self. I will explain that in a minute. And then the second thing I'm going to put in is amount, because when I start my checking account, I'm going to give it an amount to start with, an initial balance. So I'm going to do that, and then I've got to start writing the guts of my function. So the first thing I'm going to do when I get in here is I'm going to say print, you have opened a checking account with, and then I'll say amount. And that's good enough for that. And then I'm going to say self dot balance, and I'm going to set it equal to amount. And that's it. So basically what I'm going to do is when I get an actual checking object, I'm going to have an amount in parentheses, and you're going to see when we use it. And what I'm going to do is I'm going to print out you've opened a checking account with that amount, and then I do what's called creating an instance variable. All right? In the constructor is where you set up what are called your instance variables. And your instance variables, as you're going to see, are variables that only count for that one object you created. Because what you're going to learn going down the road is that this is a blueprint, and I can get as many of them as I want. So I can open up a bunch of different checking accounts. But these variables are just going to be for that one thing. Okay? Right now, because we don't have the variable name, we don't know what it's called, what the actual thing is called, which is why we say self. And you're going to learn a little bit more about self at the end of the video. I think I'm going to show you something neat at the end there. Okay? So we have our constructor. We've created our object. What's the next thing we want to do? Constructors. Classes usually have a convention where there will be two methods for each variable. And those methods are called getters and setters. You want to have a way for the person using your class to get the value of that variable and or to set it, to change it. Okay? Now, we're doing a checking account, so I'm not going to change my variable willy-nilly. I'm going to change my variable by doing deposits and cutting checks, as you're going to see, because we're going to do methods for that. So right now, I just really want what's called a getter. I want the ability to get the balance. So that's really simple. I'm going to call it get balance. Hey. I'm going to put self in there, and all I'm going to do is I'm going to return self dot balance. Done. I'm going to send back out to the real world, and you're going to see it's almost like a function. This object is going to be created and enclosed, and then you can ask it for variables, and then it sends it out. And right here, you're going to see return self dot balance. You're going to understand this a lot better when we start doing examples. So there we go. I have my getter. So the next thing I want to do, because I think it's the easier of the two, is I will create a method called deposit. And this one's going to take an amount. And what I'm going to do when it takes the amount is I'm going to say self.balance amount. I'm going to add that amount that I give to the balance. Okay, so I'm basically just going to increase it by whatever the amount is. Now, I'm not going to do the error checking, but if this were a real program or a real bank program, I would check to see that the amount was positive. I would check some other things to make sure everything was okay before I added it to the balance and had a set balance. I'll actually, you know what? I'm going to be a good doobie. Print your new balance is... And then, because I've already done the math, I can use set.balance and print that out. So that should work, and that should be good, and that'll save us the trouble of printing it out every time. That would bite me in the rear end if I left that spelling problem in there. Okay, now we have one more method left to do. We're going to say def, and I'm going to call it check because it's like cutting a check. And we're going to say self, and it's also going to have an amount. Only this time, we are going to cut a check. So we are going to do a little error checking this time, because when I cut a check, I want to make sure I have enough to cover it in my account. So the first thing I'm going to do when I say check is I'm going to say if amount is greater than self.balance, well, then what's that mean? That means I got a problem. Well, I obviously have a problem with spelling today. Let's see. That means I've got a problem, because that means I'm trying to cut a check for more than I have, and I can't really do that. So what I'm going to do in that instance is I'm going to say print insufficient funds, and then print balance self dot balance. So I'll print out my balance after that. Okay, but else, if it's not greater than, if it's equal to or less than, well, then I can do the transaction. So then I'm going to say self dot balance minus equals amount, and then just going to copy it from right there. I'm going to print that. You know what? We got a class. Do I have my tested thing there? Yes, I do. Test things. Okay? Now, we're going to trace through it as we use it, so we don't have to do that now. But right now, we have a class called checking, which has 4 methods. It has a constructor, so that when we first create the object, we're going to do all of these things. I'm going to print out that line, and I'm going to create my instance variable. We have a getter, which means anytime I want the balance, I can run that method, get balance, and it'll give it to me. I also have a deposit where I can deposit money into my checking account, and I can also cut a check where I check to see if I have enough money. And if I do, I cut the check. If I don't, I say insufficient funds, and I just print the balance. All right? Hopefully this is going to get a lot more understandable in about 2 seconds. All right. Test things. What am I going to do? L account for Lars account. I'm going to assign it the value of checking, and I'm going to give myself $300. Boom. Now, L account is a variable. It holds an object. It points to an object. It doesn't point to an integer. It doesn't point to a floating point. It doesn't point to a string. Think of an object as a data type. It points to a checking object. That is your data point, okay? What is a checking object? It's defined by this class. So now I have an object that is this. That is a checking account. So I can run get balance on it. I can run deposit on it. I can run check on it, okay? And up here, it keeps my variable. So the first thing I'm going to do, and I think we do that when we open it, but I'm just going to do it again, is I'm going to print laccount dot get balance. And you see I do it with 2 parens because I don't need any arguments. So the first thing we're going to do is run that. Look at that. First time. No errors, no typing errors. Thank goodness. Okay. So I have opened up an account with $300. Nice. So what do I want to do now? I'll say laccount dot deposit, and I'll give myself an extra $500. Wouldn't it be nice if life were like this? Because in deposit I print out my balance, I don't really need to do anything else, so I'm just going to save it and run it. So, okay, you have opened a checking account with $300. Your new balance, I shouldn't do that. I should do this. Print. You have deposited amount. So then we're going to get the good information. We're going to see you've deposited $800, and then it'll tell you your new balance. Okay? Which is why we should do the same thing here. Print. You cut a check for amount. So when we do that, that'll work too. Okay, good. So what have we done? Let's go trace through it. Okay? I created laccount. It's a variable. It's assigned an object created with the checking class. And the one variable I give it is 300. So, do I have a class called checking? I do. It's up here, class checking. I run the constructor. So what do? Print. You have opened a checking account with amount. What was amount? 300. Well, that happens right here. You have opened a checking account with 300. Okay. Then I set my instance variable. In this case, the instance is pointed to by the variable laccount. Self.balance equals amount. So self.balance equals 300 at this point. Good. We're done. Bang. Next line. Print. laccount. So what's laccount? Laccount is a variable that points to an object that was created with checking. Is there a method there called getBalance? I go to checking. Yes, there is. What do? Return self.balance. Self.balance is what? We set it up here. It's 300. Okay? So I just print that out, and as you can see, I print it out 300. So in the very last line, laccount. What's laccount? It's a variable that was assigned a checking object. A checking object is an object that was created with the checking class, which is right up here. Okay? In that checking class, do I have a method called deposit? Yes, I do. So what are we going to do? Deposit took an argument of 500. I skipped self. We'll get to that in a second. So 500 is the amount. Self.balance is what? It was 300. So now I add 500 to it. So now self.balance is going to be 800. You have deposited amount. Amount was 500. You have deposited 500. Okay? Your new balance is self.balance, which was just increased to 800. And we print that out right there. Okay? You're starting to get it? Now, if I want to do something else, if I want to say Bob's account, checking, and Bob is richer than me, that SOB, okay, he's got more money, then I can run that. And Bob has opened an account with $1,000. That's completely different from me. I can print my balance, which is laccount.getBalance, and I can print Bob's balance, bobaccount.getBalance. And this is the whole idea behind object orientation, is that I can take that blueprint and create as many objects as I want, and they're all going to have their own instance variables. So you're going to see when I print this out, I'm going to have my account, which is $800, and then I'm going to have Bob's account, which is $1,000. All right, don't make a liar out of me. Oh, dun 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 dun. I misspelled it. So now when I run it, I get 800 because that's my balance, and I get 1,000. That's Bob's balance. See? So now I have two objects going. I have my account and I have Bob's account. They both have different balances. That's what the instance variable is all about. Okay? It's the variable that pertains to that particular object. Now, we still got one last thing to do. I know I'm Lars' account, so I'm sitting $800. I'm going to try to cut a check, laccount.check, for $900. I'm writing checks that I can't cash. So, what's going to happen when I try to do that? Just for the time being, I'm going to zots out Bob, so we stick with the Lars stuff. All right, I've deposited 500. My new balance is 800. Insufficient funds. Balance 800. I should put print. You try to cut a check for, and then amount, so we know exactly what we're doing. So now when I rerun that, you have deposited 500. Your new balance is 800. You tried to cut a check for 900. Insufficient funds. So your balance is still 800. It stays the same. Okay? Hey, I don't need that. And I don't need that. All right? So now let me try something more reasonable. I have $800, so I can say, okay, let me try to cut a check for $600. And now when I try to do that, it lets me do it. It says you cut a check for $600. Your balance is $200. Okay? And as you can see, we'll go through it again. laccount, what is that? laccount holds a checking object. Okay? Check. Does the checking object have a method called check? Boom, boom, boom. It does. Self amount. What was the amount? 900. Is amount greater than self.balance? What is self.balance for laccount? Self.balance for laccount is 800. So is 900 greater than 800? It is. So I print, you tried to cut a check for 900. You tried to cut a check for 900. There you go. Insufficient funds, and then I print the balance, which is 800 because that's self.balance. It's the instance variable for that object, laccount. Okay? Now, when I do a correct amount, 600, I say, is 600 greater than 800? It's not. So I go to the else. And then I update my balance. I say I cut a check for 600, and my new balance is 200. All right? Starting to get it? Starting to see it a little bit? It's like basically you set something up and say, this is how I want the object to behave, and then you can go get as many objects as you want. All right? So we had Bob account, we have Lars account, and when you look at Lars account, you see by using the dot here, you run the different methods on the variable that you created. All right? Now, just real quickly, and I do not want this to become a point of confusion. All right? So I'm telling you to ignore self and to do self. Think of self as something that references the actual object. I don't know what the variable is at the time, but when I create it, laccount, I know that self will be laccount. So you think to yourself, oh, so self says laccount? It doesn't. If I come down here and I say print laccount.self, it's going to tell me to pound salt. It's going to say that doesn't exist. Watch. Boom. It's going to say, what? It has no attribute self. What are you talking about? But watch this. What if I print laccount? All right. Now, we're going to learn a little bit more about this in the third video. But right now, you're used to printing variables because your variables have been integers or strings or lists. And when you print them out, you get them. Well, what if I print this object out? What am I going to get? Okay. I'll show you. When we run it, main blah, 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 that looks a little kooky. But what it is a memory address. It's telling you the memory location of that particular object. Okay? And if I came in here and I said print self in the constructor, watch. Oh, sugar. No, Dippy. Look, see? It's the same address, okay? So if I print self when I construct the object and then I print it outside, you'll see it's the same address. So you're probably saying, yeah, well, that doesn't really mean that whole much. Well, watch this. See that? When I create L account, I get that address, FFF780, FFF780. When I create the second one, I get a new address, 2C50 and 2C50. So as you can see down here, the objects have different memory locations. They're different objects. Okay? That's what self does. Self refers to the actual thing. All right? But I don't know what that actual thing is called when I'm creating the class because I haven't created any objects yet. So we use self. We use self as a placeholder. But basically, self kind of contains that memory address. Like, this is where the object is. This is it, the thing. This is me. If you're familiar with the language C++, think of this. Okay, the keyword with that is this. Same thing with Java. Think of the this keyword. Okay, that's kind of what self is. It's so you can refer to the actual object without knowing what it's called yet, or without knowing what variable points to it. Because at the end of the day, they're all handles, but that's old-fashioned, fuddy-duddy terminology. But basically, a name that gets you something is just a handle for that thing, be it a variable, be it a function, be it an object, be it whatever. That's all that thing is, right? It's just, this is the name I have for that location where my thing starts, be it an integer, be it a string, be it a function, be it an object, be it whatever, anything in memory at the end of the day. They're just, be it a file, the beginning of a file handles. They're just all handles. But, as usual, I digress. You, okay, do not have to put your paws on the keyboard and start typing away, because I am going to take this and I'm going to put it up in Sakai for you, okay? I am going to go easy on announcements right now because I'm giving you another video tomorrow. I'm going to do some prep work later tonight, maybe in between the basketball games. And tomorrow, Sunday, I don't know whether I'm going to be at the cave or whether I'm going to be here in the old dining room, but I'm going to bang together, I think, 1 or 2 of the remaining videos for this unit so we can start learning a little bit more about some of the things that come along for the ride when we do object orientation, like things called inheritance and things polymorphism, and we're going to create an animal class, and then we're going to get some different classes out of it, like a cat class and a dog class. We're going to do some interesting stuff as far as that's concerned. Take your time with this. Rewatch this video. Grab this code and play around with it. Make changes. Get your own objects and play around with them and see what you can do with them. Okay? That's what this is all about. This is about tinkering and playing around. All right, then I'm going to get out of here. You be good. I'll be talking to you in the next couple days when I get you another video. All right? You be good. I'll talk to you later. Bye.